Okay.
So lesson 9.
Yep. Okay. Let's see what we have here.
Wow, it's 21 questions.
Well, number 1 is true. Number 2 is hopefully true.
Yeah.
So, which hypothesis involves equality? I'm pretty sure that's the null hypothesis. The alternative hypothesis is typically not the null hypothesis.
Yeah, I think it's null hypothesis.
The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you want to assume to be true? I do not remember.
The null hypothesis.
Let's see here. So typically the p-value, you want to reject the null hypothesis. So the alternative hypothesis is the one that you want to assume to be true. And if the p-value is large enough, then it is true.
Right.
Okay. Does everybody agree with that, or do you remember something that...
No, I agree.
Okay. The memory aid is, if the p is low, reject the null.
Which one are you on?
I think we're on 5. So
5.
suppose the null hypothesis is 10, or rather the mean is 10. Which of the following represents the alternative hypothesis for a two-tailed test? I'm pretty sure it's the third one. The mean is not equal to 10.
Yeah, that's what I was just about to say.
And question number 6, by the way, that was C. So anyways, question number 6, which of the following represents the alternative hypothesis for a left-tailed test? Mean is less than 10?
Yeah.
What would you guys say?
I think
Yeah, I think so.
one, yeah.
Okay. Which of the following represents the alternative hypothesis for a right-tailed test? Well, mean is greater than 10.
Right.
Okay.
Remember that we determine the outcome of a hypothesis test by comparing the p-value to the levels of significance, or sigma. Use the information. Which relationship would result in failing to reject the null hypothesis? Sorry, what's the sigma again?
Sigma is, I have some notes I wrote down the other day. The sigma is, sorry, let me
Good.
I don't remember.
Oh, it's the level of significance.
I had something else down.
Sigma is the type 1 error, I believe. Okay. Okay. So if the p-value is less than sigma, we reject the null. If the p-value is not less than sigma, we fail to reject the null.
Yeah.
So is it
P-value is less than sigma is when we reject the null.
So the second one.
B? Yeah.
Yes.
I always get confused with the variables.
Yeah, I do too.
Oh, sorry. The question was failing to reject the null hypothesis, so technically it'd be p-value is greater than sigma.
So it'd be
Sorry,
A.
I didn't read the question right. So for 8, it'd be
Oh,
A.
yeah, you're right. You're right. I should remember this in tutoring the other day.
Yeah, I hate doing that because like I try and like read the question and I'm pretty sure I know what it means and then don't read it right. Which relationship would result in rejecting the null hypothesis? P-value is less than sigma.
Yeah.
Question 10. So an insurance company is reviewing its its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500, $1,500. They are concerned that the true mean is actually higher than this. Which of the following would be appropriate alternate hypothesis? The average claim
I would
is
say
greater than
yeah,
1,500. So C.
Mm-hmm.
Does that sound good to you guys?
Which one did you say?
Well, they're concerned that the thing is higher, that the mean is higher than $1,500. So the
Okay.
alternative would be greater than the mean. So
Greater
greater than 1,500.
Greater than 1,500. Yeah.
Yeah.
Okay.
Which of the following would be the appropriate null hypothesis? The average claim amount is equal to $1,500.
We're on 11, right?
Yes. Sorry, I need to say that. You all good? Can we go on to the next one?
Which one for? Are we on 11 right now?
We finished 11.
Now we're on 12.
Okay. That's what it was.
So has Christina still not responded?
Christina, no. I sent her the invite.
Oh, so you did send the invite though?
Yeah, I did.
Okay, that's
Wait,
good.
so 11, did we say it was greater or less than?
11 is what? No, 11 is the same as, so equal.
Okay, the same as. Okay.
So next one says the insurance company randomly selects a sample of 40 claims and calculates the sample mean of 1650, 1,600, 550, 650. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? I say it is,
Yeah, I'd say it's a good assumption.
since the sample size is large.
Yeah.
What theorem or law justifies your answer? Central limit theorem. Which of the following is a test statistic as defined in this lesson? I'd assume X bar.
I think it's X bar.
Which one would it be? Because I don't know what Z or S is. I forget.
E is the Z score, and then S is the sample standard deviation.
Wait, sorry. S was what?
S is the sample standard deviation.
And you can't select multiple?
No, it's just one.
And then N is the sample size, right?
Yeah.
They all they're pretty much the same thing. Like they're all, shoot. I'd say X bar, but I really don't know.
Yeah, I would say X bar as well.
Let me check really fast. Actually, guys, I think it's Z.
Yeah, it is Z because in the lesson it says Z.
So,
Yep.
because the z-score is a statistic, is that why?
Well, Z is the Z score. I don't know. I think if I was to give it to my best guess, it's because we have this whole formula to find Z.
Hey guys, in the lesson it says where Z is the test statistic, X bar is the sample mean. So Z is the test statistic.
Yeah, that would make more sense. All right, let's go to the next one. So the information on this one, the historical mean of sales receipts at a grocery store is $150 with a standard deviation of 40. The store manager suspects that the average has decreased. She sets up a hypothesis test with hypotheses. She will use a level of significance sigma equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X bar equals 144.
So the z-score we have to
What is
do-
the Z-score associated with this test?
Would it be x minus mu over the standard deviation? Well, we don't know the standard deviation yet. Or is that
Well, the standard deviation was 40,
40?
but
Oh, yeah, I see.
what's
So
the
it would be,
formula
so
for
it would
this?
be x minus, so it would be, actually, because this is a group z-score,
What was that?
because it's, so this is a group z-score because it's x bar. So it's x bar minus mu over the standard deviation, which is just, and then the square root over n.
Right.
Or the deviation over the square root of n. Does someone have a scientific calculator to do that on? I mean, I have
Oh, so it's the same formula as last chapter, right?
Yeah, it's the same formula.
Okay.
Mu over.
Let's have a few people calculate that out.
I don't have a scientific calculator.
That's fine. I mean, I'm doing it right now, but let's see. So 144 minus 150 is -6, obviously.
Right.
So 40 divided by 36
By that
30.
is negative 0.15. And then someone needs to do that over the square root of
So 6.666. So it's Z-score is -0.9.
We need to put that into Applet.
Oh no, it's just asking for the Z-score right now.
So the score is 0.09, is that what you said?
Negative.
Yeah, -0.9. I think that's how she wants you to input it. What is the p-value associated with the Z-score?
It says 3 decimal places. So did it have numbers after the 9?
Okay, let's see. So p-value.
Wait, did you hear what I said?
No, what did you say, Allie?
Well, it's saying 3 decimal places. So were there numbers after the 0.9? Because I couldn't finish the problem on my calculator.
So just put 0.9 and not 0.9, is that what you're saying?
Well, because it's saying round to 3 decimal places, so is the answer like 0.952?
Right, you'd think there'd be another number.
I only got -0.900000000009.
Okay, yeah, that makes sense.
Yeah. But anyways, the next one, we have to find the p-value, and I totally forget how to do that. I was like kind of going over it before we started the call, but I couldn't get quite through it.
So let's see here.
Oh. Hello?
I'm trying to remember how to do this. Please come back to this.
Okay, so from what I'm getting here, we get the p-value by finding the area below. No,
Here, wait.
the area underneath the normal distribution curve that is more extreme or farther away from the mean than the z-score.
Hold on.
So if we use a probability applet,
What's the z-score again? It was negative 0.9.
yeah.
It's 0.184 because you shade it to the left.
Sorry, did you say 0.184?
Yeah, because you put in the z-score of negative 0.9, and then you shade it to the left because it's less than, and it's 0.184.
Okay. Yeah, you're right. So since it's so big and she was using 0.05, wouldn't we have to reject the null hypothesis, or would we have to accept it?
I would say you reject the null hypothesis.
Okay, but the p-value is negative. Sorry, it's 0.184.
Yeah, that's good.
Okay. Sorry, and our whole thing was if the level of significance is greater. I want to make sure I go over this right. So the p-value is less than. Oh, sorry. So we would fail to reject the null because the p-value is so big. Does that make sense?
Are you still on 17? I thought we already did that.
Hello?
Hello.
So you're saying fail to reject instead of reject the null.
Yeah.
Problem 17.
From what I understand is that if the p-value is greater than the whatever of significance, the sigma, then
All right, that makes sense.
And then if the p-value is less than, then we reject the null. What is your conclusion for this problem? We have insufficient evidence that the true population mean is. Sorry, we have insufficient evidence that the true population mean is less than.
So C.
Okay. Question 19. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? I think that's type 2.
Type
But
2.
okay, who said that again?
Type 2, Andrea.
Oh, Andrea, how come you said that?
Because hold on, let me reread this question, make sure.
What did you guys put for 18?
19. We're on 19.
Yeah, but what did you put for 18?
Well, because the p-value is big and we failed to reject the null hypothesis, that means that the true population mean is probably 150.
Okay.
Don't have enough evidence to say that it's less than 150, which was the alternative hypothesis. Which is C.
Mm-hmm.
So in 4.5, it says on the lesson, whether we, let's see, where does it say this? So I can show you. Fail to reject is type 2, reject is type 1.
Reject is type 1, fail to reject is type 2.
Yes.
So it is type 2.
Type 2, yeah.
Wait. No. So what you just said, rejecting is then type 1 and fail to reject is type 2. So then it'd be type 1?
Hold on. Fail to reject is type 2, reject is type 1. And yeah, so it would be type 1.
Okay.
I think.
Well, that's good to know.
But we put
So,
fail to reject. So it would be type 2.
Yeah. Wait,
Right.
but then that's saying that the
It's type 1. It's type 1.
it'd have to be type 1 because the null hypothesis is true.
Yeah.
Okay, that makes sense.
Okay. Yeah, that's type 1. All right, question 20. A researcher decides that instead of using a level of significance of 0.05, he will use a 0.01. Which of the following will be true? Null hypothesis true. Scientifically valid. I don't remember going over this in the lesson, but if I had to guess, it'd probably be type 1. Because let's just say like the level of significance like was 0.10 or whatever, 0.1. It'd be more likely that, that experiment is true, like the null hypothesis is true. But if it's type or if it's 0.01, then it might disprove it even though it is true. Does that make sense?
Mm-hmm.
Like the lower sigma that you use, the more likely that you'll reject the null hypothesis, even though it may be true.
Yeah, that makes sense.
Because if it was a type 2 error, then I feel like rather the null hypothesis is false, then it won't affect the.
You're on 20?
Yeah.
I think it's a probability of a type 2 error.
Okay, and how come?
Just because, the first one is saying, like, which one is it rejecting the null hypothesis? And so that's type 1, but this one is saying it's using different numbers.
Right, but if we're going lower in the sigma, then that makes it more likely to reject.
I went over a question like this with my tutor yesterday. Like it was pretty much the same, just worded a little bit different, and it was type 2. I can't find my notes in my binder. I'm wondering if he wrote them down.
Yeah, I feel that.
Notes or something.
I don't know. I guess my whole thing is that by decreasing the level of significance, it makes it a whole lot harder to prove the null hypothesis. It makes it a whole lot easier to disprove it, if that makes sense.
Yeah.
So like that right there, I know is true. Like anything else you want to infer off that, I'm open to listening. So if what you're saying is Sorry, can you explain yourself again, Allie? And then
Well, I don't know how to explain it because I went over it in tutoring yesterday, but I don't know how to like explain like what I'm thinking. I can't find my notes.
because to be honest, like I'm kind of looking at it right now and thinking about it, and it's just like going in one ear and coming out the next. Like I'm like trying to make sense of it, but I can't. So, probably decrease.
Well, 20. Now I'm looking at 21, and it's the same. It's 0.05 as like probability.
Well, how do you compute the probability of committing a type 1 error?
So when you do that, like a lot of the times when it's asking for probability and it gives you that variable, a lot of the times it's as that variable. Unless you want to solve for the z-score and then put it in and state it, and you can find it that way.
All right. I say we go ahead and go with Allie on type 2. Although if that one is wrong, then we can go back and put type 1.
Yeah.
When we redo it. For 21, how do you compute the probability of a type 1 error?
So for probability, you.
Because I had no idea you could do that.
I think A. Well, if you put that into the applet, I'm not sure.
Oh, you know what? What it's saying here is that 0.05 is equal to like 1/20th. So when null hypothesis is true, there's a 1 in 20 chance that it will be rejected at the 0.05 level of significance.
But still 0.05.
So basically it's 0.05, I think.
It's super stupid.
Oh wait, never mind. That's not what it's asking. Shoot.
I'm gonna put 0.05. I'm just gonna go ahead and put it. I have to go to work like right now.
You said you're putting 0.105?
I'm putting 0.05. 0.0, yeah.
05.
Yeah. And it looks
0.05 is.
Yeah, we got 23 out of 23 or 20.
So, wait, did you just submit it?
I did because I had
What did you get?
23 out of 23.
What was that? A 21 out of 21?
No, 23 out of 23.
Oh, wait. Oh, no idea we had.
Well, the 2 questions were at the beginning that you answered. Or maybe it's 21. I got 100%.
Sorry, what was that?
I got 100%. So all of our answers.
All of our answers are correct then?
Yeah.
Oh, sweet.
I gotta go, so I'm gonna end this. But I'll message Christina and see
Okay,
or what
that'd
her
be
deal
good.
is, because I don't want her to be like stuck by herself. But I'll see what
Yeah.
she says. And I'll let you guys know.
Okay, thank you.
Perfect. Awesome. Thanks, guys. See you.
Bye.
Alrighty, bye.